All right, today we're talking about inscribed angles in a circle. So an angle is inscribed in a circle if one of the vertices is on the circle, so vertex C is on the circle, and the endpoints of the angle are also on the circle. So A and B are also on the circle. So angle ACB is said to be inscribed in circle Q. So angle ACB is inscribed. Now, AB is called the intercepted arc, or the arc that is intercepted by the inscribed angle. So AB is the arc that we're talking about. Now, we already know that arc AB and X would be equal because angle X would be, or angle AQB would be a central angle, and those are equal. So what we're going to learn here is how the inscribed angle is related, and an inscribed angle is 1/2 of the arc it intercepts. So angle ACB is 1/2 of arc AB. So that means that if I were to give these some measures, so if I said that this was 60 degrees, angle C would be 30 degrees. Now we know X would be exactly the same and would be 60 degrees. So the inscribed angle is 1/2 of the arc. Sometimes finding the arc that's intercepted is the most difficult part. So I would suggest when you get stuck on a question like that you take a highlighter and that you go over and highlight your angle and you let it extend past the circle. So then we can easily see that this is the arc that we're intercepting. Okay, so this is a good example of trying to find that intercepted arc. So it tells me that arc DG is equivalent to 45.6 degrees. So here I can mark 45.6 degrees. Now I need to find what angle E and angle F. So here's angle E, right here. So if I get my highlighter out and I go to highlight angle E, I can see that the arc it subtends, or the angle is inscribed in that circle, the arc that it intercepts is that arc DG, so 45.6. So all I would have to do is take 45.6 and divide by 2, and that would give me 24.8 degrees. So this arc, right, or this angle is 24.8 degrees. Now, what's really cool is that if I go over here, let's change colors and do a different highlighter, and I look at angle F. When I highlight angle F, we notice that it subtends the exact same arc. See, they're both using, it's both being intercepted by arc DG. And so we know that it's exactly the same. So angle E and angle F are both 24.8 degrees, and they are congruent to each other. So if an angle is inscribed inside a circle and it subtends the same arc as another angle, then those angles would be congruent. Now on this one, we notice that Q is the center of our circle. Q is the center of our circle, which makes RT the diameter, which also makes RST half of the circle. So this RST is actually called, it's got a special name, it's called a semicircle. RST is a semicircle. It's half the circle. If we have an angle that is inscribed inside of a semicircle, meaning that its intercepted arc is half of a circle, so here's the other half of the circle, then that is always half of 180 or 90 degrees. This is a right angle. So if an angle is inscribed in a semicircle, the angle's measure is 90 degrees. I can think of all kinds of fun Pythagorean theorem or trig function problems that we could use, knowing that that's a 90-degree angle and we've thus created a right triangle. Okay, I love these types of problems. They are a little bit of a brain teaser, so I highly suggest if you get a problem like this on your homework that you do take the time to go ahead and redraw the picture. It will be so much easier for you if you redraw this picture rather than trying to look at it on your computer screen. So the first thing I would do is start labeling the things that I know. So like ABC is 184 degrees. ABC is right here, and that one is 184 degrees. Now, BCD is 242, so let's do a different color. BCD is 242 degrees. So I would start with the angles that I have. So I know ABC, that 184 degrees, that's really subtending this angle right here, Okay, so that intercepts that arc. So I know angle D is half of 184. So I go back over here. This guy is 1/2 of 184 because of this 184 right here. Okay, so half of 184 is 92. Okay, so now thinking about that in the same way, I can look at this arc, BCD, and see which angle does that one go with. Well, here is angle BAD, or angle A. So that would tell me that angle A would be 1/2 of 242 degrees, which would be 121 degrees. So let me clean up my picture a little bit. All right, so how do we find angles B and C? So let's start with angle B. So I know that, remember, we had that ABC right here was 184 degrees. So that means that arc ADC, so the other part of this green arc would be 360 degrees minus. So this would be 360 degrees minus 184. So that would give me 176. Well, we know that this angle right here, so if we go back and do our highlight again, here's angle B, or angle ABC, and notice that its endpoints are on the green, so I want to be half of the green line over there. So I want to be half of this, so this is going to be 1/2 of 176, and half of 176 is going to give us 88 degrees. Now we could do the same thing for angle C, but we also already know that for angle C, that all of the angles in a quadrilateral, and this is a quadrilateral, would have to add up to 360. So we know that angle C plus 92 plus 121 plus 88 has to equal 360, and that is something that we can solve. And that gives us angle C is equal to 59 degrees. So it does take a little bit of patience and a little bit of extra problem solving, but these are kind of fun little puzzles to solve.